Welcome to solverfy.
More problems on friction. Consider the system shown in the diagram. We want to determine what required force P that can lift that load of weight W. So to solve this problem, we'll just apply equilibrium to the system and do a manipulation to get results. Now, so if we consider the top diagram, we'll look at the summation of the forces in the vertical direction. We are going to arrive at W is equal to NA NA normal reaction at A cos alpha minus the coefficient of static friction, okay, sine alpha minus mu, the coefficient of static friction and the normal reaction at B. You can call this equation 1. Okay. Then if we take summation of forces along the horizontal axis, horizontal direction, we're going to arrive at NB to be equal to normal, that's the normal reaction at B, to be equal to normal reaction at A, coefficient of static friction cos cos alpha cos alpha plus sine sine alpha. So we can call this equation 2. Now we can also consider the bottom diagram. We'll consider the bottom diagram and take a summation of forces in the vertical direction. We're going to arrive at uh, NC will be equal to NC normal reaction at C, normal reaction at A cos alpha cos alpha minus mu normal reaction at A sine alpha. We can call this equation 3. And of course, we take summation of forces along the horizontal axis, horizontal direction. We are going to have along the horizontal direction, we are going to arrive at P, take sum all the forces there. P is equal to mu normal reaction at C plus N normal reaction at A sine alpha plus mu as the coefficient of static friction, normal reaction at point A cos alpha. We can call this equation 4. Now we can put equation 1 into equation 2 into equation 1. If we do that, we are going to arrive at Na, the normal reaction at A, to be equal to W as the weight there over cos alpha into 1 minus mu squared minus 2 mu sine alpha. Okay, so we'll get that one. Then we'll also proceed to get our NC. To get our NC, we know that uh, NC is equal to NA cos NC is equal to NA cos alpha, okay, alpha minus mu cos alpha minus mu and NA sine sine alpha. So all we need to do, we know what NA is. So plug NA into the equation, into this. When we do that, we are going to arrive at NC. So NC is going to give us equal to W. So plug in W where NA should be. In fact, make NA the subject of the formula there. Okay, sorry, make collect like term NA, so that you have what you have there will now be NA into cos alpha minus mu sine alpha, so that what will be left here will now be cos alpha minus mu sine, okay, sine alpha, all right, over cos, sorry, over cos alpha into 1 minus mu squared minus 2 mu sine alpha. So that's what C will give us. Okay, we've already known A. So we'll continue. Now we already know B as well. We'll plug in where we have the parameter NA in B in the equation we probably got for NB. We'll plug in A in its place in it, so that we will now have NB to be equal to W into mu uh, mu cos alpha plus sine alpha. Okay, so that should now be over cos alpha into 1 minus mu u squared minus 2 mu sine alpha. Okay, so that is for NB. So we've known NA, NB, and NC. So we can now find the force that we are talking about. So the force is P. We've already gotten the equation. Now plug in and all the other values, other what we got for NA and others, plug them into this equation. When you do that, you are going to arrive at P to be equal to W into 2 mu coefficient of friction, 2 mu cos alpha plus alpha plus sine theta, sorry, sine alpha okay, sine alpha into 1 minus mu squared. Okay, all over okay, all over cos alpha into 1 minus mu squared minus 2 mu sine alpha. So this is it. So that is the force that is required